Hello, am I audible?
Yes, ma'am. Good evening.
Yes, ma'am.
Yes. Okay, so today is our revision session for week 7 and 8. I hope my screen is visible to everyone. Okay, so let's start with week 7. Okay, so week 7 is basically the power series. So you can start now, right? Is there any problem? Or in between, if you guys have any doubt, just unmute yourself and let me know. Okay. So here we will go through some of the basic stuff of series. So first we can understand what is a series is, and then how to know that that particular series converges or not. Okay. So let's see. So you guys are familiar with sequence. So what is a sequence? So a sequence is nothing but a function from set of natural number to any set. Or in general, a sequence can be denoted by a list. So for example, A1, A2, A3, and so on. These are the terms of sequence. That is first term, second term, third term, and the nth term, and so on. Now, what is a series? If you add all these terms, then whatever structure you will get, that is known to be a series. So what is a series? So series is A1 plus A2 plus A3 plus and so on. This is known to be a series generated by a sequence AN. So this thing also can be written down summation n is ranging from 1 to infinity AN. Okay, so now here this thing is actually a notation for series. Okay, so as like in sequence, we answer the question that if n goes to infinity, where does the terms of sequences goes? So that is known to be a convergence of sequence, right? So same type of convergence we also want to understand in terms of series. Okay, so what does that means? So that means that if you take the infinite sum, so that means if you want to find out the infinite sum, that what is a1 plus a2 plus a3 plus and so on plus an plus and so on. So where does this infinite sum converges? What will be the value of this infinite sum? This is the question we want to answer. Okay, so now what we know something about convergence of a sequence. So what we will do, we will extract one sequence from the series, and the convergence of that sequence is actually same as the convergence of series. Okay, so what is that sequence? That sequence is actually sequence of partial sum. Okay, so from the series, so here is the fact that from the series, summation n is ranging from 1 to infinity an, we can construct a new sequence. And that sequence I'm denoted by Sn. Okay, what is the sequence Sn? So here I'm taking S1, that is the first term of sequence is nothing but A1. I'm taking the second term, that is S2, is actually A1 plus A2. The third term will be A1 plus A2 plus A3, and so on. And the nth term of this sequence will be A1 plus, that is the sum of the first term, n terms in the series, and so on. Okay, so that means if you have a series, then you can actually construct a sequence which is denoted by Sn, and this sequence is actually known to be a sequence of partial sum. Right, now what we will do, we will say that the series is convergent to if okay, so I'll just write it down. So we say that the series summation n converges if and only if the sequence Sn converges. Right? And we understand what is the meaning of convergence of a sequence means its limit should exist, right? And that should be a finite number. That is the meaning of convergence of a sequence. So what does we saying? We are saying that the sum of the series is actually nothing but limit of this sequence S. Okay, so that's how we actually define the convergence of a series. So I'll repeat what we have learned so far. So we know what is a sequence is. Sequence is just a list of elements A1, A2, A3, and so on, An. This is also known as the function from set of natural number to any other set. So this type of functions are actually known to be a sequence. Now what is a series? That if you add all terms in the sequence, then whatever structure you will get, that is known to be a series. So series is nothing but a1 plus a2 plus a3 plus and so on. And it is denoted by summation n is ranging from 1 to infinity a. This is the notation for series. Okay. Now what we want to understand is, we want to understand that what will be the value of this infinite sum. That means if you add infinitely many numbers, then what will be the value for that? Okay, so this is the question we want to answer. So ultimately what we want to answer is how we can understand the convergence of a series. Okay, so this is the thing we want to understand. So for that, what we have done, okay, we know that what do we understand by convergence of a sequence. So we will try to assign a sequence to this particular series. Okay, so I have a series. I have a one original sequence an, and I am adding all the infinite terms of this sequence an and constructing a series. So an is a sequence and summation an is a series. Now in this series also I can construct one more new sequence. That sequence is known to be a sequence of partial sum. So what is sequence of partial sum? It is a sequence Sn whose terms are, the first term is a1, the second term is the sum of two terms, that is a1 plus a2. Third term is sum of three terms, a1 plus a2 plus a3 and so on. So the nth term of this sequence will be sum of all n terms. Okay, a1 plus a2 plus a3 and so on up to a. So now what we are doing, we are saying that the series converge if and only if the sequence Sn converges. So that means now we are relating the convergence of a series with the convergence of a particular sequence, and that sequence is sequence of partial sum. So ultimately we are saying that the infinite sum is actually nothing but the limit of this particular sequence, and which is kind of true, right? If you take n goes to infinity, the Sn will become the infinite sum only, right? A1 plus A2 plus A3 plus and so on. So it's kind of makes sense. It's connecting, right? So this is the meaning of convergence of a series. Now, usually the convergence, for finding out the convergence of a series, we have some test which we apply. In our course, we will learn three basic tests actually. But in those tests, we focused on the root test and the ratio test first. Okay. So before that, let's discuss some of the basic series, uh, which is one series, which is actually the geometric series and the P series. Okay. So I'm not going in detail of the proofs. So you guys know the proofs. So I'll just state the facts first, and then we can have a look at those results of fact. Okay. So first series is actually a geometric series. Yeah. Is there any doubt so far? Anything which is not clear about the convergence? See, this is the basic idea. Okay, fine. So geometric series. So geometric series means any series of this form. You can take A or you can just start with one. In a Okay, so we have started only with one. So geometric series means if you have a series like this, summation r to the power n. N is ranging from 0 to infinity. That is 1 plus r square plus r cube plus and so on. This is known to be geometric series. One particular example we can take. Suppose the series summation is ranging from 0 to infinity 2 to the power n. This is an example of geometric series. Also, summation n is ranging from 0 to infinity 1 by 2 to the power n. This is also an example of geometric series. So that means here what is r? R could be any real number. We don't have any restriction over r. So you can take any real number and you can talk about the series. Okay. So this is geometric series. Now what will be the sequence of partial sum here? So sequence of partial sum Sn will become 1 plus r square plus and so on plus r to the power n. This is your sequence of partial sum. But here the fact says that the geometric series converges. Okay, let me first relate the Sn with r. Okay, so this is the value of Sn. Similarly, um, we can find out the value of rsn, right? Rsn will be r plus r square plus r cube plus and so on plus r to the power n plus 1. I'm just multiplying, multiplying by r. Now if you look at the term s minus r of Sn, then what will happen? This r and this r will get cancelled out, r square get cancelled out and so on. See, at the end we are left with 1 plus r to the power n plus 1. right? Because every term here also r to the power n will be there, that will be cancelled out. So that means s minus r Sn is nothing but 1 plus r to the power n plus 1. So from here you can find out the value of Sn. So Sn
Ma'am,
is actually
minus
nothing but
1 minus r to power n
oh
plus 1.
yeah, right. 1 minus, we are subtracting. So 1 minus r to the power n plus 1. So this is 1 minus r to the power n plus 1 upon 1 minus r. Okay. So now we got the sequence of partial sum in something nicer form, right? It's not a summation, it's a single term where we know that r is nothing but a real number, right? Okay. So now here let's see the involvement of factor n, because what is the meaning of limit means we want to see that if we take n goes to infinity, where does the term of sequence goes. Okay. So what we will do, we'll just take out all the terms which involve n, small n, and then we can look for the limit. Okay. So this thing can be written down 1 upon 1 minus r, and then minus with r to the power n plus 1 upon 1 minus r. Okay, so here what we observe that this is a constant factor. So n goes to infinity does not affect this factor. So it's not a use of. Now here also this is a constant thing. So okay, it behaves nicely as n goes to infinity. It stays constant. So the only thing which changes r to the power n plus 1. Okay, so now if we take different values of r, we can discuss that as n goes to infinity, where does r to the power n plus 1 goes. Okay, so here, let's see if you take the value of r to be any number which is strictly greater than 1. So you can take r to be equal to 2. Okay. So if r is equal to 2, then what will be the limit? Limit n goes to infinity, 2 to the power n plus 1. What will be this limit?
0, ma'am.
N goes to infinity, 2 to the power n plus 1. Are you
Go
sure,
to
Sandeep?
infinity.
Infinity, right?
Yeah.
Yeah. So that means if you take any value of r which is strictly greater than 1, then this Sn also goes to infinity. So that means the series is not convergent. So here we get the fact that if, okay, at the end we can write, but that's right. So if r is strictly greater than 1, then we are getting Sn is actually going to infinity, because this term is going to infinity, r to the power n plus 1. So r to the power n plus 1 goes to infinity means Sn also goes to infinity. So Sn goes to infinity, so that means the series not converges. Okay, so now let's take the second one. When the value of r is equals to 1. Okay, so if the value of r is equals to 1, then what is this series? Summation r to the power n is actually 1 plus 1 plus 1 plus 1 and so on, infinitely many times. So in this case also, we are not converging to something. That means this sum, this infinite sum is not becoming a finite value, right? So in this case also, the series summation r to the power n not converges. Okay, is that clear? These two facts?
Yes, ma'am.
Okay. Now let's take the value of r. So here you can also talk about the modulus of r. See, if modulus of r is strictly greater than, for example, if you take the value of r to be strictly less than minus 1. Okay. So you can take an example. So suppose r is equals to minus 2. In this case also, you guys know that limit n goes to infinity, this minus 2 to the power n plus 1 is not have a, it's not a particular finite value, right? It will become infinity or minus infinity. It oscillates. So this limit actually does not exist. So in this case also, the series does not converge. So ultimately, summarizing all these facts, what we got that if the value of r, if the modulus of r is strictly less than 1, then this implies summation rn converges. And where it converges, that the value of series is actually this term, 1 upon 1 minus r. Okay, so that means if modulus of r is strictly less than 1, then the series converges, and where it converges to the value 1 upon 1 minus r. Now, and the second fact says that if the modulus of r is greater than or equal to 1, then this implies summation rn does not converge. Okay, so this is the fact about geometric series. See, here I am talking about the simple geometric series. Simple geometric series means I am not involving a factor. For example, okay, so let me ask you guys now. So, okay, so can you guys tell me what would be the sum of this series? Summation 3 upon 2 to the power n. You can take 2 minutes. And then you can answer. Answer in the chat box. I'm looking at the chat box. Okay, 6, half, half. Okay, so let's try to solve this one. Okay, so first of all, what is this series? So the series is summation n is ranging from 0 to infinity 3 by 2 to the power n. So this is nothing but if I elaborate it a little bit, so you'll get that this is nothing but 3 plus 3 by 2 plus 3 by 2 square plus 3 by 2 cube and so on. Okay, so what we know that the summation n is ranging from 0 to infinity r to the power n, that is 1 plus r square plus and so on. This is actually equal to 1 upon 1 minus r. Okay, so first of all, we need to convert this series into this particular form. Okay, so we know that the series summation n is ranging from 0 to infinity 3 by 2 to the power n. This can be written down as, we can take common 3, right? Because 3 is common in each and every term. So you can just pull out 3, and the series is actually summation n is ranging from 0 to infinity 1 by 2 to the power n. So here you will get the value of r is actually equal to 1 by 2. So that means the series actually 3 times the convergence of this summation of 1 by 2 to the power n. We know that this is a geometric series and the value of r is actually, so if you consider the modulus, it is only 1 by 2, and which is strictly less than 1. So that means it converges, and where it converges to 1 upon 1 minus r. So that is 1 upon 1 minus 1 by 2. Okay, so that means what is this? This is 3 into 1 upon 1 minus 1 by 2 is 1 by 2 only, and this 2 will jump into numerator, and you will get 3 into 2, which is nothing but 6. So that means the value of this sum 3 upon 2 to the power n is actually 6. So the purpose of this example is, whenever you apply the formula, you have to remember this form, that summation r to the power n. This particular form is 1 upon 1 minus r. So if it's starting with some constant, or if it's not starting with 1, that's also you have to take care. Okay. So the answer is actually 6. So this is one series, geometric series. There is another series which is known to be the P series. Okay. So this is the second fact. So what are P series? P series are actually series of the form summation 1 by n to the power p. Okay. Where here we are taking p to be any fixed real number. So you can talk about the series of summation 1 by n, 1 by n square, 1 by n cube, and so on. These are examples of P series. For example, I can take the series of summation 1 by n, summation 1 by n square, summation 1 by n to the power 1 by 2, and so on. These all are examples of P series. So P series are actually though of the series of the summation 1 by n to the power p. Okay. Now we want to understand the convergence of the series. So that we will do with comparison test. So if you guys want the proof, you can just go and look in the lectures. I'll just state the result. So result says that if the value of p is less than or equal to 1, then the series, then summation 1 by n to the power p, this series does not converge. It diverges. And the second fact says that if the value of p is strictly greater than 1, then this converges. Okay, so if you want the proof of this thing, you can just go and look in the lecture. It was done by comparison test. So I'll come to that too. But this is the fact you should remember, that if you have a series summation 1 by n to the power p, then it diverges if the value of p is less than equal to 1, and it converges if the value of p is strictly greater than 1. Okay. Okay, fine. So let me ask you a simple question. So summation 1 by n to the power 1 by 2, this converges or diverges?
Diverges.
Diverges, right? Because here the value of p is actually 1 by 2, which is less than 1. So that means this diverges. Okay, so this is a very simple fact about P series, but it's very strong. So we will use P series to find out convergence and divergence of other series too. Okay, so now let's get back to our test.
Excuse me. I,
Yeah,
I have a
yes,
doubt over here.
mm.
The conversion and divergent of this summation doesn't depend upon the n value, whether it is less than 1 or
No,
greater
no, no.
than.
See, when we are writing summation 1 by n, that means n is ranging here. N is going from 0 to infinity, sorry, 1 to infinity. Here also n is going from 1 to infinity. So that means we are changing the value of n. P is already fixed. So first we will fix P and then we talk about the P series.
Okay, yeah, okay, got
Right?
it.
N is varying here.
Yes.
Okay. So this is our P series. Now, how to check that a particular series is convergent or divergent? So we have some particular step. So one result is, it says that if summation an converges, then the limit of this particular sequence an is actually equal to 0. So then limit n goes to infinity, an is equal to 0. Okay, so this is the result. And how it is true? So see, we know that what is Sn. So Sn is actually a1 plus a2 plus and so on plus an. Now what is Sn minus 1? Sn minus 1 will be a1 plus a2 plus and so on plus an minus 1. That is the sum of n minus 1 term, sum of n terms. That is Sn and Sn minus 1, sequence of partial sum, right? So here, if you compute the value that Sn minus 1, you will get an back, right? So that is Sn minus 1. So because a1 cancel out, a2 cancel out, and so on, an minus 1 also cancel out, you will get an back. So that is an can be written down Sn minus 1. And we know that what is the meaning of summation an converges? It means that the limit of sequence of partial sum exists. Okay. So here, if you take the limit n goes to infinity, of Sn minus 1, this is same as limit n goes to infinity of an. But what is happening? We know that if Sn converges, then Sn minus 1 also converges at the same place, because there is a difference of only one term, and the difference of one term does not change anything, right? So I think you guys know this fact that see. So this will implies that this limit is actually 0. Since we know that limit n goes to infinity Sn is same as limit n goes to infinity Sn minus 1. Okay. because both sequences are eventually same. It is starting, there is only a difference of one term. So Sn is a sequence starting from, you can say 1, 2, 3, 4, and Sn minus 1 starting from 0, 1, 2, 3, 4, and so on. So it's just a one term different. So both sequence converges to the same limit. So that's why this is equal to 0. Sorry. Okay, so this is the first result. So that means if you got a series, and in a series, if summation, and in that series, if limit n goes to infinity, an does not converges to 0, you can directly imply that the series is not convergent. Okay, so this is the very first step you have to check when you talk about the convergence of a series. If they haven't given explicitly that which test you want, they you have to apply. Okay, so let's take one example over that. So here is a question. So does the series summation, okay, so I'll take 3n plus 2 upon n plus 1 converges or diverges? Okay, so suppose someone give you the series summation 3n plus 2 upon n plus 1, and if they ask you that figure out that this converges or diverges, what would be your answer? You have everything on screen to say it converges or not.
Converges.
Are you sure? See here, what is the limit of n goes to infinity of an? It actually diverges. Yes.
Ma'am, it's that. Ma'am, limit is 5 by 2, I guess.
This is 3. 3 by 3 will be limit, right?
3 is the limit.
See, here I was asking you to apply the fact. So what is the fact says? Fact says that if series converges, then limit n goes to infinity, an is 0. So if an is not 0, that means the limit is not converges. So that means here you have to use this particular fact that if limit n goes to infinity, an is not equal to 0, then the series diverges. Okay, remember this fact. If limit of an is not 0, then immediately you can say that that series will diverge. Okay, so here, what is your an? What is the sequence an? What is the sequence an?
3n plus 2 upon n plus 1.
Right. So that is 3n plus 2 upon n plus 1. See, always remember na, how we are writing the sequence, how we are getting the series. It's summation of an. So whatever here you will get, that is your sequence an. So here in this case, an is actually 3n plus 2 upon n plus 1. And this an also can be written it down. You can just pull out n from the numerator and the denominator. You will get 3 plus 2 by n and upon 1 plus 1 by n. And here if you apply limit n goes to infinity of an is equal to 3 plus limit n goes to infinity of this term 2 by n and 1 plus limit n goes to infinity of this term 1 by n. We know that 2 by n and 1 by n both goes to 0. So this goes to 0, this goes to 0. So this limit is 3, which is not equal to 0. So that's why this series actually diverges. Okay, so this is the first thing you have to check, that if a series converges or not diverges. If the limit is not 0, you can immediately say it is diverges. But if the limit is 0, then we cannot conclude surely that it converges or diverges. Okay, so the converse of this result is actually not true. So converse is not true. What do you mean by that? That means if limit of an is 0, then we can't say anything surely, right? For example, uh, Summation 1 by n. This series converges or diverges? Summation 1 by n
Diverges.
diverges, right? By PE series test, this diverges. And but here what we get? What is the limit of En?
0.
0, right? So here we are getting limit of En 0, but the original series diverges. So that means if you get limit of En 0, you cannot conclude convergence. But if limit of En is not 0, you can definitely conclude the divergence of series. Okay, is that clear? Fine.
Yes, ma'am.
So this is the first thing you have to check about convergence of any series. Now the second test comes as our root test. So if you get that limit n goes to infinity is 0, then you will go to the root test. Okay. So root test for checking the convergence and divergence of a series. So in root test, what we will do, we will compute a particular limit, and according to that value of that limit, we will conclude that a series converges or diverges. Okay. So root test goes like that. So suppose, so here you will compute the value L. What is L? L is actually limit n goes to infinity of this particular term, that is modulus of En to the power 1 by n. And again, we are talking about the series summation En. So you can take En from that. So suppose L is this limit, then depending on the value of L, we'll conclude that a series converges or diverges. So then if if the value of L is strictly less than 1, then you can conclude summation En converges. If the value of L is strictly greater than 1, then you can conclude summation En diverges. And if the value of L is equal to 1, then this test actually fails. Then you cannot conclude anything. This actually fails. Okay. So you can also say no conclusion too. But this is the root test we have to apply. Okay. Now let's have an example for that. So summation 1 by n to the power n. Okay, so suppose this is the series you have, or else let's take one simple example. So summation 1 by 3 to the power n. Is this converges or diverges?
It converges.
It converges. Actually, it's a geometric series, so you can also tell by the value of R2, but you can also apply a root test here. So if you apply root test, so answer is actually convergence.
If we apply, yes.
If you apply root test, you will get the value of L to be 1 by 3, right? So what
Yes,
is L?
less than 1 by 3, which is less.
Right. So this is modulus of 1 by 3 to the power n to the power 1 by n.
1 by
Right?
n.
But this modulus turns out to be positive only because we are taking positive numbers only. That is 1 by 3 to the power n. So this is same as talking about limit n goes to infinity of 1 by 3 to the power n to the power 1 by n. And we can, this 1 by n and n will cancel each other. That is limit n goes to infinity of 1 by 3 to the power n into 1 by n. This will be cancel out. And the value of L is actually 1 by 3, which is less than 1. So we can say that summation 1 by 3 to the power n converges. Okay, so that's how you can apply root test. Now similarly, we have a ratio test too. So actually what happened in root test, we have to compute this limit. But sometime it would be difficult to compute this particular limit. So in place of this, we can compute another limit. And again, based on the value of limit, we can conclude that a particular series converges or not. It's known to be a ratio test. Okay. So in ratio test, which limit we will conclude? We will say that if L is actually limit n goes to infinity of modulus of En plus 1 upon En. So if this is the value of L, then based on the value of L, we can conclude the same result is actually true. So we'll say that, okay, so then if L is less than 1, this will imply summation En converges. If L is greater than 1, then this will imply summation En diverges. And if L, the value of L is equal to 1, then this test actually fails. Okay, So this is the root test, sorry, ratio test. Now let's take an example for this too. Suppose you have a series summation 1 upon n into n plus 1. And we want to figure out this converges or diverges. Okay. So you guys can take 2 minutes or we can just solve it. Oh, in place of this, let's take interesting one. This already you can easily figure out. So suppose you have summation 1 upon n factorial. Okay, so suppose this is the series we have and we want to find out the convergence and divergence of this series. Okay, so I'll do it. So solution. So in this case, what you will do, see here there is no involvement of power n, right? So you have to remember whenever you apply root test, there should exist some power of n, like 3 to the power n, so that you can cancel out 1 by n and n. That's a simple reasoning. But here there is no power of n. If you want to compute the nth root of this particular an, it will be a little difficult. So that's why we go with the ratio test. Okay, so we have to compute this particular limit. So here, what is your an? So an is actually equal to 1 by n factorial. So what will be an plus 1? An plus 1 will be 1 by, in place of n, we will take n plus 1. So that is 1 by n plus 1 factorial. Okay, you guys are familiar with factorial, right? N factorial means n into n minus 1 into n minus 2 into and so on up to 3 to 1. This is the meaning of factorial. Now what will be the limit here? So the value of L will be limit n goes to infinity of modulus of an plus 1 upon an. Right? So this is same as limit n goes to infinity of modulus of an plus 1 is actually 1 by n plus 1 factorial upon 1 by n factorial. So let's rearrange it. But again, we can leave modulus thing because here we are talking about positive numbers only. So modulus won't affect anything. So this is same as limit n goes to infinity of n factorial, n plus 1 factorial will come into denominator and factorial will go into numerator, right? Simple arrangement only. So now here this thing also can be written it down. What is n factorial? N factorial is n into n minus 1 into n minus 2 into and so on up to 3 to 1. Right? What is n plus 1 factorial? N plus 1 factorial is n plus 1 into n minus 1 into n minus 2 into 3 to 1. Right? So here all these terms will get cancelled out. So at the end, what we are left with 1 upon n plus 1. And what is this limit? What will be the value of this limit?
0.
0. Right? So that means what we get? We get that L is equals to 0, which is less than 1. So that means summation 1 by n factorial actually converges. Okay, so that's how you can apply the ratio test. Is that clear? Fine. Any doubt?
No, ma'am.
Okay. Okay, so far we have talked about 3 facts. First fact is you have to check about limit n goes to infinity en, if this is 0 or not. Second thing is if that is 0, then you can go to the root test or ratio test depending on the expression of the series. If it involves some power of n, then root test would be better. If it is not involving, if it is involving a simple like factorial type of thing which can be easily solved using ratio test, right? So you have to use ratio test. Now with these two tests, we have one more test which is known to be a comparison test. Okay, but comparison test is a little bit tougher to apply because in that test you should know other series too. So I'll just state down what is a comparison test is. So as the name suggested, we have to compare our given series with some another series. Okay, so suppose you have a series summation an, and there are actually two statements. So first statement says that if the modulus of an is less than or equal to cn for all n above some steps, that means finitely many initial finite terms actually does not matter. So if you have this particular condition and if you have one more known quantity about CNS and if the series summation Cn converges. So ultimately what is happening? You are just building a block about the term Cn. We are restricting the series An with some convergent series. So if modulus of an is less than equal to Cn, and if summation Cn converges, then you can say summation an also converges. So this is the first thing. Now the second statement says that if 0 is less than or equal to some dn is less than or equal to an, and we have that summation dn diverges. Okay, so see the combination. First combination is if modulus of an is less than or equal to Cn and summation Cn converges. Then we can say that summation n also converges. Second combination is if 0 is less than or equal to dn is less than an and summation dn diverges. Then you can claim that summation en also diverges. Okay, so this is known to be a comparison test. But comparison test is a bit difficult to apply because here we should guess what series will work as our Cn and what series will work as our Dn, right? So that's why it's a little tough to apply. But you can apply whenever you have a polynomial type of series. Okay, so this test is useful if you have this type of series. So let's take an example. So if I ask you that the series converges or diverges, suppose you have a series summation 1 upon n square plus 2n plus 1. Okay. So is this converges or diverges? Okay, think about 2 minutes and you can answer. See which series you can compare it. And mostly this type of series, that rational type of series, that is 1 upon something, will you can easily handle with comparison test. I'll just give you a short trick too, but before that, let's understand this one. Okay, try to answer it if it is converges or diverges. Hint is use a P series to compare. Yeah, that's also true that it is 1 upon n plus 1 whole square, but that does not affect that much. Okay, so actually this series converges. So here what is happening? We have again uh, what is our an? An is actually 1 upon n square plus 2n plus 1. Now here your goal is either you can find a Cn or you can find a Dn. So first of all, you should have an idea that which Cn or Dn will work. Okay. So here, what is the leading power of n? So the leading power of is n square. Okay. So what can I say? So I can say that since we know that the value n square plus 2n plus 1 will always greater than or equal to the value of n square, right? Because in n square you are adding something. You are adding 2n and then you are adding 1. So that means the value n square plus 2n plus 1 will always bigger than or equal to n square. Is that clear to everyone? This particular fact, right? So what you can say, okay, so as we take the reciprocal, we know that the inequality will change. So that means the value 1 upon n square plus 2n plus 1 this actually less than or equal to 1 upon n square, right? So now this 1 upon n square will work as a Cn. So here what we get, again there is nothing special about modulus because here everything is positive. So we can say that modulus of 1 upon n square plus 2n plus 1 is also less than or equal to 1 upon n square. So this is your an, and this will work as a Cn. So what we get? We get that modulus of an is less than or equal to Cn. And also we know that by P series, the summation 1 by n square converges, right? Because the value of P is strictly greater than 1. So this converges, and we have this inequality. So that means by comparison test, you can see that summation 1 by n square plus 2n plus 1, this also converges. Okay. So see, whenever you have such type of series 1 upon some polynomial of n, right? If you have this type of series where you are getting 1 upon some polynomial of n, this is polynomial in it, then just by looking at the power of n, you can say that that series converges or diverges. If the power of n is strictly greater than 1, then you can immediately say that is convergent. If the power of n is strictly less than 1, then you can immediately say that will diverges. Okay, just because of the comparison test. Okay, so let me ask you one question. That if we have a series summation 1 by n to the power 2025 plus n to the power 2024 plus and so on plus n square plus n plus 1. Okay, now is this converge or diverge? It seems horrible series, right? N to the power 2025, 2024 and so on. Why it diverge? Converge, right?
Yes, sir. Convergence.
So see, just by looking, as I told you earlier, you can compare the series with the series n to the power 2025, right? So solution, I can write it down. See, here we know that n to the power 2025 plus n to the power 2024 plus and so on plus n square plus n plus 1. This is always greater than or equal to n to the power 2025. And you can just take the reciprocal, so that is 1 by n to the power 2025 plus and so on plus n plus 1. This is less than or equal to 1 by n to the power 2025. So that means this will work as a Cn. And we know that summation Cn, which is 1 upon summation 1 by n to the power 2025, this converges. So by comparison test, we can say that An also converges. Okay, is that clear? It's not a GP actually. See, if you write down the term, then you can see that it's actually not a GP. GP has a little, because here in the denominator you will get other and other factors, so it's actually not a GP. Yeah, the denominator is, but as n approaches to infinity, you're getting sums, right? That is okay. So if you take the value of 1, n is equals to 1, you'll get 1 only. If you take n is equals to 2, you'll get 2 to the power 25 plus and so on. I hope you. Yeah. Okay, so this is actually a comparison test. Similarly, you can use P series to say that some series is divergent or not. For example, if I ask you that about a series 1 upon n plus 1, then the series will diverge. You can also use the comparison test for that. Any doubt?
No, no.
Okay, fine. So this is actually a comparison test. Now, okay, so let me just give you a question. See if you guys can remember something. So See, if you have a series like this, suppose 5n cube plus n square plus n plus 1 upon n plus 1, or n to the power 5 plus 1. Okay. Now, is this converges or diverges? It could feel a bit tricky, right? But try to observe something. Try to observe the power of
Diverge.
it. Are you sure diverge?
It converge.
Yeah, actually it converges. But how it converges? Okay. So see, here you have to understand that there is a difference of 2 power in the numerator and the denominator, and in the denominator, right? So you can use the comparison test, and also you can use some known facts to us. Okay. So what you can do, you can simply see that yeah, I want to say the same thing only. That n to the power 5 plus 1 is actually greater than equal to n to the power 5. And then this upon 5n cube plus 3n square plus n plus 1. So ultimately what you can say that this whole thing can be dominated by the series, I mean this convergence of this series will be same as convergence of the series of 1 by n square. Right, y n square, because here we have power 3, here we have power 5, here we have power 3. So if you take out the largest power from the numerator, what you will get? You will get that 5n cube plus 3n square plus n plus 1 upon this n to the power 5 plus 1. This is same as summation of 5 plus 3 by n plus 1 by n square plus 1 by n cube. And in the numerator, you will get n square plus 1. Right? So ultimately, I'll just write it down nicely. So this is same as summation of, we have n square plus 1 here, and here we have 5 plus 3 by n plus 1 by n square plus 1 by n cube. Right? So ultimately what happened, the nature of this power series will become similar to the nature of power series 1 by n square because of this factor 1 by n square. So that's why this converges. So if you got such type of series, although it's a tough example, it's not the clear explanation, but you can get some idea that which series converges and which not. Okay, just looking at the powers of n. Okay, so that's all about series so far. So I'll quickly remind what we have done. Okay, so first thing is, first of all, you have to check for the limit, that limit n goes to infinity, en is 0 or not. Okay, so if it is not 0, then you can say that summation series diverges. Okay, so if it is 0, then you have to go to the second test, and the second test could be either the root test or the ratio test. Right? If you think that both are applicable, then you can go for them. If they are not applicable, then you can go for comparison test. And in comparison test, you have to use either the geometric series or p series to compare any series. Okay, that's up to your intuition, that which series you think it's would be easier to compare. So in comparison test, you have to either use geometric series or the p series. Okay, so this will be a roadmap for finding that a particular series is convergent or not. Meanwhile, in some cases, they will ask you to apply a particular result itself. So that means they will ask you by the ratio test which series is convergent, by the root test which series is convergent. So that will be easier to handle. Okay. I hope that's clear. So that's all about series. Now we can go to the power series thing. So what is power series? Is that clear? Any doubts so far? Let me know if I move too fast. Okay. Okay, so what is the power series? So power series is basically, in place of series, we have a variable in that series. So for example, a series like this, e n x to the power n, where x is a variable, right? So this is known to be a power series. So this type of series is actually known to be a power series. So in place of simple series, we have a variable in that series. So it looked like a polynomial, right? Or infinite degree polynomial type of thing, right? You can take an example. So suppose I have a series of this, right, nx to the power n. This is a power series, right? You can just find out the terms. So that will be n. If I'm taking n is ranging from 1 to infinity, it would be x plus 2x square plus 3x cube plus 4x to the power 4 plus and so on. Okay, so such type of series are known to be a power series. So that is a series with a variable. Okay, now here also we want to understand what is the meaning of convergence, right? So in power series, convergence and divergence depend on the value of x. So that means what value of x you are choosing, and then after that which series you are getting, and then you can ask about convergence and divergence. So here, generally asking convergence or divergence, in place of that, we ask for what values of x the given series converges. Okay. So here which question we ask? See here we ask for what value of x the series converges. Okay, because here, see, if you substitute any particular value of x, you will get a known series. Known series means, for example, the series I can take. That is a general geometric series also can be represented by a power series, right? So you can simply take summation x to the power n, and this power series, right? This power series converges for the value of x is equals to 1 by 2, right? Because here in this power series, if I take the value x is equals to 1 by 2, if I simply put x is equals to 1 by 2, which series I'll get? I'll get series summation 1 by 2 to the power n, which is nothing but a geometric series, right? So that means this particular power series, so in this scenario, what you can say? You can say that, here we can say that for x is equals to 1 by 2, the series summation x to the power n converges, right? So this is the question we will answer in terms of power series, that for what value of x you will get a convergent series. Okay, I hope that's clear. Is that okay? Fine.
Ma'am, can you repeat this?
Yeah, so here what we are doing, so see, what is a power series? Power series is nothing but a series with a variable in that, that is a and x to the power n. X is a variable. So for example, this series summation n is ranging from 1 to infinity n x to the power n, right? So if you just take the value of n's, if you take n is equals to 1, you will get 1 into x, that is x. If you take n is equals to 2, you will get 2x square, 3x cube and so on. So a power series is nothing but a general series but a variable with it. Okay, now in the power series, in place of convergence, we ask a little different question, that for which value of x you will get a convergent series. That is the question we ask. That means here we ask that for what value of x. So that means if you put a value of x in that power series, you will get something else, right? You will get a normal series. For example, in this power series, summation x to the power n, if you put the value x is equals to 1 by 2, you will get a simple series, summation 1 by 2 to the power n, right? So if you put x is equals to 1 by 2, you will get a convergent series. But if you put x is equals to 2, then what you will get? You will get summation 2 to the power n, which is not convergent, right? So that means depending on the value of x, whatever you substitute in your power series, the convergence and divergence of series varies. Okay. So here we want to figure out that for what value of x you will get a convergent series, and for what value of x you will get a divergent series. Okay, so this is the thing we need to answer. Okay, so here also you can see the second case would be if we put x is equals to 2 in the series summation x to the power n, we get the series summation 2 to the power n, right? Which is not convergent, right? So for this series, what we got, so that means for series summation x to the power n, we get that For all values of x, for all x, which modulus of x is less than 1, the series converges, right? Summation xn converges. And for all x greater than equal to 1, the series diverges. This is just a geometric series fact. In place of r, I have write down x. Okay. So here we get this thing. So this is the question we want to ask in general for any power series. That which set of values of x are there for which we get a convergent series. Okay, so that means whatever value of x you will put, you will get a convergent series back. Is it clear? Okay. So now finding that is actually finding the radius of convergent of a series. So let me see what is the radius of convergence first. Okay, so radius of convergence is actually that value of r for which if you take any x value in between the interval minus r to r, you will get a convergent series. Okay, so I'll just write it down. So suppose summation e n x to the power n is a power series. You have a power series, and for any x belongs to the interval minus r to r, the series. Okay, so I am taking x naught, any particular value from minus r to r. If you take, then the series summation a n x naught to the power n converges. And if you take any value of x naught outside of this interval, and for any x naught does not belongs to minus r to r, the series summation a n x naught to the power n diverges. Right? So then this particular r is actually known to be a radius of convergence. So radius of convergence is this. So that means if you consider the interval minus r to r, and if you pick any value of x from that, any x naught from that, and if you consider the series summation n x naught to the power n, then the series converges. And if you take any x naught outside of that interval, then for that series diverges. It's known to be then that particular r is actually known to be a radius of convergence. So for any power series, we want to find out that particular r. Okay, so now here there are so many unstated fact that why this always be an interval, why it look like minus r comma r, but all these things you can understand once you go through some higher mathematics course. Okay, so for time being, a radius of convergence means that value of r for which if you pick any x naught from the interval minus r to r, the series converges, and if you pick any x naught outside the interval, that would be diverges. Okay, is that clear? Fine. Yeah. So for power series also, for computing radius of convergence, we have a test which is known to be a root test. So let me write it down, root test. ROC means radius of convergence. Okay. So here also for a power series, you will compute a value of limit. What is limit? So let us assume that alpha is actually limit n goes to infinity of modulus of a n to the power 1 by n. Again, what is a n? If your power series is looking like a n x to the power n, then this guy is your a n. So that is whatever term is there with x to the power n, it's known to be a n. Okay. So if alpha is limit n goes to infinity modulus of a n to the power 1 by n, then the radius of convergence that the value of r depend on the value of alpha. So then the value of r is actually 1 by alpha. If alpha is not 0 or infinity, the value of r will be 0 if the value of alpha is infinity, and if the value of r is and the value of r will be infinity if the value of alpha is 0. Okay, so by this thing you can easily compute the radius of convergence. You just have to compute limit n goes to infinity in modulus of n to the power 1 by. Okay, is that clear? Fine. Okay, now using power series we have defined exponential function. That e to the power x is what? It is 1 plus x square plus x cube plus and so on. This is known to be a power series for functions. So that is for functions also we have some power series. Okay, so I'm not going in detail that how to define a function using power series because we have to cover integration too now. That's why. Okay. So for power series, two things you should understand. One is radius of convergence. That what does it means? It means that value of r for which if you take any x naught outside of that interval, series will be divergent. If you take any x naught inside the interval, series will be convergent. And how to compute radius of convergence? We have a root test for that. Okay, that's all. These two things are important in the topic of power series. Okay, now let's go to Riemann sum and integration. Is that clear? Fine. Any doubt so far from power series? If in place of x. Yeah, so if you have x to the power 2n minus 1 or something like that too, then also I think it converges to same thing. I mean, see, in our course we haven't learned about x to the power 2n minus 1 type of thing. So there is something else. It's yeah, you won't get anything like that x to the power 2n minus 1 because there are 2 to 3 cases which can happen. So don't worry about that. In power series, you always get x to the power n type of term only. Okay, you won't get any other power of x because we haven't stated any result yet. Okay, now let's go to the integration part. Okay, so I'll briefly state what is the idea of Riemann integration. So the thing is, we want to answer the question of if you have a graph. So suppose if you have this type of graph, then what I want to answer is up to some bound, that is up to these two lines, x is equals to a and x is equals to b. I want to find out what is the area of this region. Okay, so for that, what we have done, we will consider some rectangle strip over this whole interval and try to shrink the width of those rectangular strips in such a way that it will approximate our area. So for example, if I consider rectangles of okay, height of the rectangle, so see, let me just see right down here. So see, if this is the rectangle, then there are two factors of rectangle, right? One is its height and another one is its width or breadth, what they say, I don't know. Okay, so for height we always consider the function value. Right, function value means if this is your function f, then you can take this point as the height of the rectangle and you can build a rectangle. Okay, you can take this value as the height and you can build the rectangle. Okay, so for height we always take a function value, but for width we consider the values over the x-axis. So that is the part, that's how the partition and all those things comes into picture. Okay, so don't bother about that now. Okay, so in Riemann integration, what we want to do, we want to consider a very smaller and smaller rectangles so that it can cover the area here, and we can find out the approx area by just taking a very smaller and smaller rectangular strip. This is the idea. Now for doing this mathematically, we need some tools. The tools are partition, the left Riemann sum, right Riemann sum, and all those things. Okay, so I'll just briefly state how to compute left Riemann sum, right Riemann sum, mid Riemann sum, and then we can go to integration. Okay. So first of all, you should know what is the interval and how to partition the interval into regular parts. Okay. So if I ask you, so suppose I want to partition matlab divide only the interval For example, I have the interval closed interval 0, 5, and I want to partition this interval into 5 regular parts. 5 regular subintervals. Regular subinterval means the length of each subinterval should be same. So what would be your answer? You will say simply, okay, you can take a small interval like 0 to 1. The length of this interval is 1 only, right? 0 to 1 means 1 minus 0 length is 1. So if you have an interval a comma b, the length will be b minus a. Okay. So 0 to 1 will be your first interval, 1 to 2, second interval, 2 to 3, third interval, right? 3 to 4, and then 4 to 5. There you, right? We have a 5 regular subinterval. But this is easy case. But what happen in place of 5 regular subinterval if someone asks you to break this interval into 50 regular subintervals? Right? Now this will be a tough thing, right? How you can just guess. So for that we have a formula. So what does that formula say? You will just use 5 minus 0 by 50 as the length of each subinterval. Okay, so that is the length of each subinterval will be 5 by 50, that is 1 by 10. Right? So you'll take first subinterval from 0 to 1 by 10. Second subinterval will be 1 by 10 to 1 by 10 plus 1 by 10, whatever that quantity is, and so on. So briefly, by using this example, I want to tell you this fact that if you want to divide a comma b interval into n regular parts, then the length of each regular part will be each regular subinterval will be that will be b minus a by n. Okay, so can you guys tell me if I want to divide the interval 0 comma let's take it 8 into 4 subintervals, what will be the length of each subinterval?
2.
2, right? 0 to 2, 2 to 4, 4 to 6, 4 and 6 to 8. Okay, so this symbol only you will get. You won't get any 50 or 100 type of subinterval, only simple intervals. Okay, so this is the first step for computing any left Riemann sum or right Riemann sum. First of all, they will ask you, you have some interval and you want to divide that interval into some regular parts. Okay, this is the first step. If you figure out that, then what is a left Riemann sum? So suppose I have the interval close interval a comma b. I'm dividing this interval into n regular parts, and the n subintervals are this intervals that I'm writing it as x naught only. See, x naught comma x1, where x naught is the value of a, then x1 comma x2, and so on, xn minus 1 comma xn, where xn is your b. Okay, so suppose you have divided the interval into n regular parts, and these are the n subintervals. Okay, now what will be the left Riemann sum? So left Riemann sum is actually, see, this is the interval. So let me write down here. So if you have an interval like xi minus 1 comma xi, then for this interval, this is the left endpoint. This is the right endpoint, right? So when you are computing left Riemann sum, you have to consider the function value at the left endpoint. Okay, and what is the length of the each subinterval? Del xi. Del xi is actually xi minus 1. This you know. But whenever you are dividing into n regular part, this del xi will be fixed. That is nothing but b minus a by n. Okay, so this del xi you know. Del xi is actually xi minus 1. Okay, so left Riemann sum says you have to sum the value of function on the left endpoint, that is xi minus 1 with del xi, where your I is ranging from 0 to n minus 1 or 1 to n minus 1. And if I elaborate it, it look like this, that f of x0 into del x 1, right, plus f of x1 into del x2 plus and so on, plus f of xn minus 1 into del x n. This is left Riemann sum. So in left Riemann sum, you have to consider function value at the left endpoint. Okay. In right Riemann sum, you have to consider the function value at the right endpoint. Don't worry, we'll take an example so that will be much clearer. Okay, so in the right Riemann sum, we'll take function value at the right endpoint. That is f of xi into del xi. So if you elaborate it, it look like f of x1 del x1 plus f of x2 del x2 plus and so on plus f of xn del xn. See, you can find out the difference. We started with x0, x1 up to xn minus 1. Here we started with x1, x2 up to xn. That's the difference between left Riemann sum, right Riemann sum. And in mid Riemann sum, we'll take the middle value of the interval as the function value. Middle value means, what is the middle value of interval means? It's average. So that is x0 plus x1 by 2 and so on. It's known to be a mid Riemann sum. So mid Riemann sum goes like summation I is ranging from 0 to n minus 1 f of xi plus xi minus 1 by 2 del xi. That is simply f of x0 plus x1 by 2 into del x1 plus and so on. You can write it. That is the meaning of mid Riemann sum. So the only difference between left Riemann sum, right Riemann sum, and mid Riemann sum is taking the function value at which point. So if it is a left Riemann sum, you have to take the function value at the left end point. If it's a right Riemann sum, you have to take the function value at the right end point. And if it's a mid Riemann sum, you have to consider the middle point of the interval. Okay, is that fine? Clear? Let's take an example that would be much clearer. Okay, so very simple expression I'll take so that we don't have to do much calculation. Otherwise, it would be a little calculative if you take complex expressions. Okay, so find left, mid, and right Riemann sum for the function f of x as 2x plus 1 by dividing close interval 0, 10 into 5 regular parts. That's how the question also looks. You will have some function, you will have some interval. They will ask you in how many parts we have to divide, and you have to answer. Okay, so take
Okay,
2 to 3 minutes.
can we place 5 with n regular parts?
You can place, but then calculation will be tough to find. That's what I was saying.
Okay.
Yeah, you can. I think in see, if you place n, then you have to think that what would be that compact form will be. So it's not that required. It's okay if you understand this much only, then that's also okay. You can place n. It will take a little time, but you can do. Okay, so after this, I'll place n and I'll try to do. Okay, so just give me the value of left Riemann sum, right Riemann sum, and mid Riemann sum. Answer in the chat box. Okay. Hello, I'm audible?
Yes, ma'am.
Okay, so let's solve this question. So see, first of all, we have the interval, close interval 0, comma 10, and we want to divide this interval into 5 regular parts. Okay, so what will be the length of each subinterval? So length of, so this will implies that length of each subinterval, or this is also known to be a delta, right? So delta will be b minus a by n. So that is 10 minus 0 by 5, that is 10 by 5, and that is 2. So that is length of each subinterval will be 2. And what are those subintervals? So length will be 2 means I have to just start from 0 to 2, then 2 to 4, then 4 to 6, 6 to 8, and 8 to 10. These are your subintervals. Okay. So for left Riemann sum, what I need to do is I want to calculate function value at left endpoints multiplied by delta. Right. So that would be equal to f of 0 into delta plus f of 2 into delta and plus f of 4 into delta, f of 6 into delta, and then f of 8 into delta. Right. So I can take delta common, that is 2 common, and just have to compute f of 0 plus f of 2 plus f of 4 plus f of 6 and plus f of 8. Okay, so what is our function? Our function is 2x plus 1, if I'm not wrong. 2x plus 1, right? Yeah, 2x plus 1. So if you just substitute the value, you will get, if you take 0, you will get 1. If you take 2, you will get 5. If you take 4, you will get 9, 6, 13, 8, 17. Let me know if I'll do any wrong calculation. Okay, so these two will become 30, 40, 45, right? 2 into 45, that would be 9. This is your left Riemann sum. Okay, is that clear? Calculation and how to compute. Any doubt?
No, ma'am.
Okay. Similarly, you can calculate right Riemann sum too. So right. In right Riemann sum, we'll take the right endpoint as the function value and same delta too. So I'll take delta common again. So right endpoints will be f of 2, f of 4, f of 6, f of 10, f of 8 and 10. F of 6, f of 8 and f of 10. Right? These will be right endpoints. See. 2, 4, 6, 8, and 10 right endpoints. So if you compute the value, so here you will get 5, here you will get 9, here you will get 13, here you will get 17, here you will get 21. Okay. So again, these two will become, right, these two will become 30. These two will become 30 again. So 30, 30 will be 60 and 65. So we have 2 into 65. 2 into 65 will be 130. Right? So this is your right Riemann sum. Similarly, you can calculate mid Riemann sum. In mid Riemann sum, you have to consider the midpoint. But here the intervals are easy. Right? The midpoint of 0 to 2 is 1. Right? 1 will be the midpoint. Here the 3 will be midpoint. 5 will be midpoint. 7 will be midpoint. 9 will be midpoint. Right? Midpoint means just can take an average of both endpoints. That's all. Average, or you can take 2 minus 0 by 2, 4 minus 2 by 2, 6 minus, not 4 minus 2. 4 plus 2 by 2. Midpoint, right? Average. That would be your midpoint. So mid Riemann sum will be delta multiplied with function value at midpoints. That is f of 1 plus f of 3 plus f of 5 plus f of 7 plus f of 9. Right. So delta f of 1 will be what? 3. The 7, 11, 15, 19, I guess. Okay. So this is 2 multiplied by, this will become 10, right? These two become 10. These two again will become 30. So 30 and 10 will be 40. 40 and 10 will be 55. 55 multiplied by 2 will be 110, right? So this is your mid Riemann sum. That's how you can calculate mid Riemann sum, right Riemann sum, left Riemann sum. Now, in place of n regular parts, if they ask you about, in place of 5 regular parts, if they ask you about n regular parts, so what would be the change? Okay. So here, in place of 5, if we take n regular parts. So if you take n regular parts, then what will be the value of delta? Delta will be b minus a by n. Right? B is 10, 10 minus 0 by n. That is 10 by n. Okay, so now the delta value will change to 10 by n. Now, what will be the left endpoint of each subinterval? You have to guess. Okay. So, see, the first endpoint. So, what are the subintervals now? Subintervals will be 0, comma 10 by n. Then 10 by n, comma 10 plus 10 by n plus 10 by n you have to do. Right? That will be 20 by n, if I am not wrong, right? 10 by n plus 10 by n, 20 by n. And then 20 by n to 30 by n, and so on. So it's in place of that, it's like see, this is 1 into 10 by n, this is 2 into 10 by n, this is 3 into 10 by n. What I want to say is like this one. This is simply 1 into 10 by n. This is what? This is 2 into 10 by n. This is what? This is 3 into 10 by n. Up to and so on. You will do it up to n into 10 by n. Up to what time? Up to n into 10 by n. That this point will be n minus 1 into 10 by n to n into 10 by n, right? N into 10 by n, but this is same as 10 only. So that's the generalization you have to make when you talk about n regular parts. You have to figure out what would be the left endpoint, right endpoint, up to n, right? Up to the value of n. Okay. Is that clear so far? Okay. So now here, what will be the left Riemann sum? Left Riemann sum says delta I can take common. The left endpoint, that is f of 0, then plus f of 10 by n, then plus f of 20 by n, and then plus and so on up to f of n minus 1 into 10 by n. Okay, so here we are talking about n in general, so n will be there always. So this is what? So delta is 10 by n only. F of 0 is 1. Right? F of 10 by n is actually 2 into 10 by n plus 1. Right? And this will be 3 into 20 by n plus 1. Plus and so on. Plus n term, if you take, that will be 2 into n minus 1. 10 by n plus 1. So that's the generalization you will get. Now you just have to solve it and write it down in terms of n. That's why it would be a little difficult if you place n there. Okay, so you can do the left calculations. Is that clear? How to solve if there is an n? It will be a little difficult. That's what I want to say. And also we generally never use Riemann integration to find the integral. We always use the fundamental theorem of calculus and an antiderivative to compute the integrals. You guys know, right? But it's okay. This is the starting point of integration theory, maybe. Okay. Now let's go to the next topic, which is the antiderivative. As the name suggested, antiderivative means a reverse process of derivation. So here, so we say capital F is an antiderivative of small f if its derivative, that is f dash, is equals to small f. Okay, so if capital F dash is equals to small f, then you will say that capital F is actually an antiderivative of small f. Okay, so you can take an example of that too. So example like if you take f of x is simply x plus 1, then what are the antiderivatives of this f of x? Okay, so one antiderivative you can consider f1 to be simply what? That x square by 2 plus x. Right? This will be a one antiderivative, capital F1, right? Because if you consider capital F1's derivative, it will become 2x plus 2 plus 1, which is nothing but x plus 1, which is your small f. But in place of this capital F1, you can also take x square plus 2 plus x plus 2 also, right? So because again, if you compute f2 dash also, you will get x plus 1, which is your small f. So that means antiderivative is not unique related to a function. It can't be unique, right? So this means that antiderivative is not unique. Okay, so this antiderivative is actually denoted by the indefinite integration. So here, what is this capital F? This capital F of x is actually written as down that integration of f of x dx. The indefinite integration is same as the antiderivative. Okay. In our course also we have adopted a notation capital A script F, right? That's also for antiderivative. Now there is a fundamental theorem of calculus which actually relates antiderivative with definite integration, right? So fundamental theorem of calculus. This theorem actually saves us from all the chaos we have to do in Riemann integration thing, right? You don't have to make partition. You just use fundamental theorem of calculus to compute the integration. It says that integration a to b small f of x dx is actually equal to capital F of b minus capital F of a, where what is capital F? Capital F is an antiderivative of small f. This is known to be a fundamental theorem of calculus. We use this theorem to compute all the integration. Okay, is that clear? Fine. Now we have several properties of integration. So I'll list it down every property. So these are basic properties. So first property is you can distribute the integration over the sum and product of two functions dx. You can take plus or minus and just written it down. F of x dx plus or minus integration a to b g of x dx. Okay, you can also take common a to b c times f of x dx, same as c times integration a to b f of x dx. I think you guys are familiar with these rules, right? The next rule is something like this, that if f of x is less than or equal to g of x, then this will imply integration a to b f of x dx is less than or equal to integration a to b g of x dx. And these are simple basic rules you can also find in the lecture slides. Okay, so here is one important property. So first of all, what is even function? So even function means a function which satisfies this property that f of minus x is same as f of x. It's known to be even function. You can consider the example of f of x is equals to x square. X square is an even function. What is odd function? Odd function is a function with this property that f of minus x is equal to minus of f of x. So known to be an odd function. You can take x cube. Okay. So those are even and odd function. So with respect to even and odd function, we have a property which says that integration a to b f of x dx is same as integration minus b to minus a f of x dx, or integration minus a to a f of x dx is equal to twice of integration 0 to a f of x dx. Okay, so I'll write it down. This property says that if f is even, then integration minus a to a f of x dx is actually equal to twice of integration 0 to a f of x dx. And if f is odd, then we have integration minus a to a f of x dx is actually equal to 0. Okay, so these are important properties about f is even or f is odd. Okay, so far now we left with only two conditions, with two methods to find integration. One is integration by substitution and another one is integration by parts. So integration by part just follows the, yeah, we can do an example. I don't have example right now. Let me check. Yeah, you can compute the example. You can find the. Okay, so this is the example of integration minus 1 to 1 of modulus of x dx. What do you guys think? What will be the answer? It's easy.
It's 1.
1. Okay. So see how we can do. So we can also do it by using a minus 1 to 0 and then 0 to 1, or you can also use this property. So we know that f of minus x is what? This is modulus of minus x. But modulus of minus x is same as modulus of x, which is f of x. That means here we are getting f of minus x is same as f of x. That means f is even. Right? If f is even, this is same as integration twice of 0 to a, that is 0 to 1, modulus of x dx. But in 0 to 1, modulus of x behaves like x only. So this is same as twice of 0 to 1 x dx. And this integration goes like x square by 2 from 0 to 1. This is what? This is twice of 1 by 2 minus 0, which is 1. Right? That's how you can use the properties. There are complex example in your activity. I haven't considered any example for these properties. Okay. Now let's go to the second part, which is integration by parts. So integration by parts is something like rules for finding the integration of two functions which are in multiplication, right? So it simply says you can remember, you can use any of the formula. Any formula means a formula given in our lectures, or a formula of integration by parts which you recall from your high school. Both are okay. So it says that integration of a to b f of x g of x dx. You have to consider the first function and second function depending on which has a very simple derivative, right? For example, if you have, there is a rule called isolate or something, right? You can use that rule. It says that f of x g of x integration of this with the limit a to, I'm sorry. So this is actually equal to f of x into integration of g of x dx with the limits a to b minus of integration a to b, the derivative of f dash of x into integration of g of x dx and the whole dx. And this is just a formula. It will be understandable once you practice some questions over this thing, right? That's why I'm not emphasizing over these property, because these are just written down property. It won't get handy until and unless you do a little bit of practice of this thing. Okay, so let's solve one question in this way. So question is to find out integration of log x. Okay, so what is the value of ln of x dx? What do you guys think? What is the integration of log x?
1 upon x.
Integration of log x. 1 upon x? No.
X into 1 minus ln x.
Right. X into 1 minus. Actually, what happened? We know that derivative of log x is 1 by x. So integration of 1 by x will become log x. We don't have any closed form for log x. We can find out what is the integration of log x by using integration by parts. We can consider 1 as our first function and log x as our second function. Okay, so we know this thing. We know derivative of ln x is equals to 1 by x. Okay, so what you will do? You will say that this is nothing but ln of x dx is actually integration of 1 into ln of x dx. So we'll take this as your first function f of x. You'll take 1 as the second function g of x. So you'll integrate 1, you'll differentiate ln of x. So this is same as, first of all, ln of x as it is, integration of 1 dx, then minus of integration of derivative of ln of x, which is become 1 by x, into integration of 1 dx and the whole dx. So this is same as now ln of x. This integration will simply become x minus of integration of, this is 1 by x into x dx. So this got cancelled out. You'll just have 1 That is x ln of x minus x. So this is the integration of ln of x dx. Is that clear now? So that's the integration by part. See, these all integration techniques won't be easy for you if you don't do practice. It depends on how much practice you have done. Okay. Now the second method is substitution, integration by substitution. Okay, so as the name suggests, we have to substitute something in our integration to make it a little simpler. For example, if you have integration of this integration a to b f of g of x into g dash of x dx. Right, so suppose you have this complex integration, then what you can do, in place of g of x, you can consider t. So you can take, let us suppose t is g of x, then you can simply replace this thing g dash of x dx by dt, because we know that dt will become g dash of x dx, and you can also change the limits too. So if x is equals to a will imply t is equals to g of a, and x is equals to b will imply t is equals to g of b. So if you g of b, if you make all these changes, this integration will simply change into g of a to g of b f of t dt. This is known to be substitution, a theoretical method substitution. You can take an example over this. So for example, that find the integration 0 to 5 x e to the power x square minus 1 dx. Okay, just take 1 minute to solve this. Again, the hint is you have to use in integration by substitution. So figure out which function you have to substitute. You have to consider as your g of x. Okay. Okay. Yes, Nitish.
Ma'am, I have a question regarding graded assignment. There is a question where it was asking that which graph is includes the negative area. So there is a three graphs which include
Uh,
three negative area,
yeah,
but the options.
there is a problem. There is a problem with that question. They actually
But the
means
my
larger negative area actually.
but there is no mention about that.
They
The
haven't
total
mentioned.
area.
Yeah, we have to change that question actually. They haven't mentioned it.
Okay.
Okay, so let's solve this one. So here you have to, obviously, we don't know the integration of e to the power x square minus 1. And also, if you take x square minus 1 as your g of x, you will get x into dx as the dt part, right? So here the substitution will be, so let us assume that t is actually equal to x square minus 1. Then you will get dt is actually equal to 2x dt, dx, I'm sorry, 2x dx, right? 2x and minus 1 will become 0, so dx. So you can change x dx by 1 by 2 dt. Okay, and the limit will be as if you take x is equals to 0, this will imply t is equals to minus 1. And if you take x is equals to 5, this will imply t is equals to 24. Right? 5 square minus 1, 24. So that means the integration 0 to 5 x e to the power x square minus 1 dx will change into integration minus 1 to 24. X dx will become dt by 2 and e to the power t will get. Okay, is that clear so far? Yes. So this is 1 by 2 integration minus 1 to 24 e to the power t dt. We know that integration of e to the power t is e to the power t only. So this is 1 by 2. This is e to the power t of the limit minus 1 and 24. So this is 1 by 2 of e to the power 24 minus of e to the power minus 1. This will be your answer. Okay, so that's how you use integration by substitution. You can do other
You share
examples too.
these notes as well.
Yeah, I'll share over the calendar. After the class, I'll upload. Within 5 minutes, you can find.
And ma'am, the previous one as well for the week 5 and week 6 as well.
Week 5, week 6, I think sir have taken. No? Let me see. If I have any notes, I'll upload them too.
Actually, I told him, but there is no update regarding that.
Hmm. Let me see if I have or not. Okay. Yeah, that's all from week 7 and week 8. So I'll recall what are the topics we have done. So first we started with the series. What is a series and some test. After that we have gone through power series. And the radius of convergence we need to find out. After that we have talked about a little bit of Riemann sum. But mainly the finite cases only when we have to compute left Riemann sum, right Riemann sum, mid Riemann sum. After that we have shown some integration. I haven't spent that much time on integration because see integration is depend on your practice. It's not something I can teach or I can solve, right? The much you think, the better you get in that those stuff. That's fine. Okay, so we have gone through some integration. Now one left thing is area under the curve. So you guys know if you have a figure like this, if this is your f of x, and if you want to find out the area of this region A, when x is between A to B, then you know that the area is actually integration A to B f of x dx. So that's how you can compute area under any curve. Just the formula of integration. So this. Okay. Now you guys can ask any question from activity practice or if you have any doubts.
Ma'am, can you just look into the mock fast question?
Let me see if I have the mock. There will be any other revision session for mock, right? Is there any session for mock?
No, ma'am.
No, ma'am, I don't think so.
Yeah, I don't have mock. Yeah, I do have mock. Sorry. Yeah, which question? Can you read the
The
question?
first one. The first one.
Ma'am,
Consider the two
the first
functions
one.
f of x, g of x. This one?
Let me check, ma'am.
Yes,
Because
ma'am.
it
Yes,
may happen.
yes, ma'am. This one. I'm getting the answer is
Yes,
0.
ma'am. 0, but it's showing us 28 is the correct
Yeah.
answer.
In my one is also okay. So let's see what is the question is. So the question goes like this. So consider two function f of x and g of x such that f of 1 is equal to 2, g of 2 is equals to 1, f dash of 1 is equals to minus 5, g dash of 2 is equals to 4. Then we have to find out the value of f of g of f of 1, the whole derivative, minus of f of g of 2, the whole derivative. Okay, so first of all, this thing that g of f of 1, the whole derivative. So by chain rule, this is actually g dash of f of 1 into f dash of 1, right? That means this is g dash of what is f of 1? F of 1 is 2 into f dash of 1. F dash of 1 is minus 5. So what is g dash of 2? G dash of 2 is 4. So 4 into minus 5, that is minus 20. Okay, is that clear so far?
Yes, ma'am.
Now f of g of 2, the whole dash. So this is f dash of g of 2 into g dash of 2. So that is f dash of what is g of 2? G of 2 is 1. So f dash of 1 into g dash of 2 is again 4. So f dash of 1 is what? F dash of 1 is minus 5. Minus 5 into 4 is minus 20 again. So yeah, minus 20 minus 20 will become 0. So answer is 0 actually. They have mistaken over here. Answer is 0.
And for the 12th one also, can you check the options, please? Because I am getting the second option as correct, but the correct answer showing in the portal is option number 1.
This Riemann sum equals this one?
Yes, ma'am.
Okay. So let's see. So here function is given to be f of x is given to be x square plus 1. Be a function defined in the interval minus 1 to 5, divided the interval into n regular parts. Okay. So what is the value of delta? Delta will be b minus a by n. Right. So that is
6 by
5 minus by n. So that is 6 by n. Okay. So right. So they are just asking about right Riemann sum. So if 6 by n is the length, then what are the right endpoints we have to consider first of all? Okay. So intervals will go like minus 1 to minus 1 plus 6 by n. Right. So that will be minus n plus 6 by n. And then minus n plus 6 by n. Okay, I can take only this is also fine, right? So, then next point will be minus 1 plus 2 into 6 by n. That is minus 1 plus 12 by n. That is minus n plus 12 by n. Right, so minus n plus 12 by n. The second interval will be this. Similarly, you can find the third interval. Third interval will be minus 1 plus 3 into 6 by n. That is minus n plus 18 by n. So I'm just trying to find a pattern. Minus n plus 12 by n, comma minus n plus 16 by 18 by n, and so on. At the end, you will get n into 6 by n. So that is minus n plus n into 6 by n, and so on. This would be minus n plus n minus 1 of 6 by n, comma minus n plus n into 6 by n. Right? This will be your last interval, nth interval, right? This will be your first subinterval, second subinterval, third subinterval, and this will be your nth subinterval. So if you want to write endpoint, you have to consider these points as the function values on the function values. Okay. So right Riemann sum will be, I'll take delta common. We have f of minus n plus 6 by n, then plus f of minus n plus 12 by n up to f of minus n plus 6n by n, right? So this is same as 6n. So you can take it as 5n by n. You can take it as 5. Is that clear? So I am taking 5.
Yes, ma'am.
Okay. So this is 6 by n. And f of this quantity we have to check. That is what? X square plus 1. Okay. This is 6 minus n by n, the whole square plus 1. Then again plus of 12 minus n by n, the whole square plus 1. And up to so on. 5 square plus 1, that is 25 plus 26. Okay, so let me see if we got any luck over here. So this is 6 by n. This is 6 minus n, the whole square by n square. Plus, now we can count the ones over here, right? So f of 5 is that. And before that, okay, we can take this as 25 plus 1. So that I can count the number of ones, how many ones are there. So this is your first, second. So how many terms are there first of all? So there will be n terms, right? Because we are taking right Riemann sum. So each interval will contribute one term. So we are dividing into n sub terms. So all these one will get calculated n times. So that means from these ones, you can take plus n. Is that okay? Why I'm writing plus n?
Yes, ma'am.
Because we are taking one n times. N sub intervals are there, so we are calculating n times function value. So that's why there will be n ones. We can take plus n plus 25 as it is. No, it's not the end. This is n plus, or else, yeah, let's write it down. 12 minus n by n the whole square plus 18 minus n by n the whole square plus up to and so on. At the end, we got plus 25. I'll see. See. Okay, so can we do over here? So how you guys solve this one? Any hint?
Ma'am, first of all, I approached it using, like, I generalized first I generalized the point. I took a variable xi, which will be equals to -1 plus I 6 by n,
Okay,
where
okay,
I,
okay.
yes, ma'am, like
Hmm.
that I approached
So
it.
you have gone through by the series, right? Summation I
Yes,
is
ma'am.
ranging
Yes, ma'am.
from 0
Yes,
to.
ma'am. Yes, ma'am.
Mhm.
Like that.
Yeah,
In
yeah,
that way, I approached it.
yeah. I think that would be okay. So if you do in this way, that will be delta summation I is ranging from 0 to n minus 1. We can also take 1, and this will be f of xi, right? So that is delta summation I is ranging from 0 to n minus 1. And this is f of, we have to multiply I over here, right? Or I can go from 1 to n for Riemann, for right Riemann sum, right? That will be I into 6 by n, right? This is the thing you have done, right?
Yes, ma'am.
Hmm. Yeah, correct, right. So this is your delta is
But
what?
ma'am, here the our the endpoint in the given interval is starting from -1, not 0. So it will be -1 plus I 6 by n. Our function will be like, the function will be is equals to uh, f of xi will be, we can write it as f of -1 plus 6i by n whole square.
Right, 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 right. Okay, okay, got it, got it. So I mean, this is not the exact I multiplied by 6i. This is actually um, this thing, right? That minus 1 plus I into 6 by n.
Yes, ma'am. Yes,
Now
ma'am.
I can take I is ranging from 1 to n. So this is same as minus 1 I have to take, right? This is the
Yes,
thing you're saying. Hmm. So in place of delta, we have 6 by n. So I'll replace that value later. So n, this is f of 6i by n minus 1, right? So this is delta now. This is summation I is ranging from 1 to n. We can take the value to be f is x square plus 1. So that is f of, this is 6i by n minus 1, the whole square plus 1.
Yes, ma'am.
So now this delta we can multiply later. The summation I is ranging from 1 to n. This is 6i by n minus 1, the whole square, plus n. Yeah, this is now 6 by n I can take. If you multiply over the sum, it will be as it is. This is 6i by n minus 1, the whole square. And plus the 6 by n multiplied by n will become 6 only. Right? So that's 6 we have. Now here also we have to summation I is ranging from 1 to n. I'll just opening the square. So that will be
Yes, ma'am. Just
36
open the square. Yes, ma'am.
I square. And then plus summation I is ranging from 1 to n. That will be minus 1 square will be 1 only. And then minus of whatever left we here will get 2 into minus 1 into 6i by n. So that will
Minus
be what,
12 by
minus 12i by n. So this is minus of, I can take 12 by n common. Summation I is ranging from 1 to n, I only. Similarly, here also I can take 36 by n square common. 6 by n. And I think I am missing this plus 6. So just remember this plus 6 is there. So this will become 36 by n square. And summation I is ranging from 1 to n, I square. Then plus of this also become n. Right? And minus of 12 by n. Summation I is ranging from 1 to n, I. And then plus 6. So here you have to use the formula of sum. That summation I is ranging from 1 to n will be what? This is what? There is formula, right? 6n
It's
some formula.
yes. For the it depends upon the function. If I square, then it will be n whole
Uh-huh.
into n plus 1 whole into 2n plus 1 whole divided by
Right, right.
6.
N into n plus 1 into 2n plus 1 by 6, right?
Yes, ma'am. For I
And if
square.
this is for I square and this is for I, this is n into n minus 1 by 2.
And
And plus, ma'am.
Yeah. N into
it's
n plus
plus
1 by
1. Yes, ma'am.
2. Mhm. Okay. And surely it starts from 1, right? I is from 1 to n. 1 to, yeah, 1 plus 2 plus n, so 1 plus n. Okay. So we have to use these two forms. This is 6 by n. This is 36 by n square multiplied by now n into n plus 1 into 2n plus 1 by 6. Right. Now plus n is there, minus 12 by n is there, and then into n plus 1 by 2. And then plus 6 we have. Is that okay so far?
Yes, ma'am.
Okay, this is 6 by n. Now we have to do a little simplification. So 6 times this will get over. We have 6 by n square here. And this n can cancel it out. This can cancel it out 6 times. So what we left with 6 by n square. Here we have factor of, okay, we can take n also, right? So we left with 6 into n plus 1 into n to n plus 1 upon n. And then plus n. And then minus of 6 into n plus 1. And then plus 6. I hope we are doing the good
Yes,
right
ma'am. It's
calculation. This will become minus 6 and minus 6. So you can take this as minus 5 and minus 6. Right. So this will become 6 times n plus 1, n plus 2, n plus 1 on n minus 5 n minus 6 and n plus 6. So this is equal to 6 by n. Again, we have to open it. We can take LCM as n. If you open it, these two bracket multiplication will become 2n square plus 2n plus n, that will be plus 3n and then plus 1. Right? 2n square plus 2n. Yeah. And if you multiply by 6, it will become 12n square plus 18n plus 6 minus 5n plus 6 minus 6. Is that clear? Is that okay?
Actually, from the above step, I the way I approached, as I saw in the options that it's not opening the bracket, so I just
Hmm.
took the combination.
Hmm. That's also you can do. But let's try to do this way too. There will be a little change, right? I'll just have to take care of the calculation. This is 2n square. This is n plus 2n, that is 3n, and then plus 1. So 2n square plus 3n plus 1. If I multiply 6 there, I'll get 12n square plus 18n plus 6. And then LCM is n. So that will be minus 5n square and minus 6n. So this is 6 by n. Here you will get what? 12n square minus 5n square. That will be 7n square. I think I'm sorry, 8n square, no? 7n square.
It's 7.
7n square plus 16n minus this will be plus 12n plus 6 by n plus 6. Okay. So LCM will be n square now. Okay. So we have to look for the options too. 36 they have taken common. So we can take common 6 overall. Right? And just multiply by 1 by n. So that will be 7n square plus 12n plus 6 by n square. So we have n square over here and we don't have anything over here, right? So that means LCM will be n square and plus 6n square. I hope this.
And plus n square. We have already taken 6.
We have already taken common 6, right? Thank you. Still we are not getting closer to the option. So let's see. That will be 8n square plus 12n plus 6. So what 6? This. Yeah, you have to check by the options too. So the answer is 36 n minus 1 the whole square n by 12. Yeah, I'll check this in meantime and I'll let you know. I have to sit and do. Up to this is okay, right?
Yes, ma'am. Actually, from the above, I haven't simplified that it as a minus 5 and minus 6. From the yes, ma'am. From
Mm-hmm.
that above step, I just took the
Mm-hmm.
common 6n plus 1 from the above and then simplified it. So I was getting it as 36 multiplied by n plus 1 whole divided by n the whole square plus 12. But
So
in the
in place of
option,
minus, you are getting plus, right?
yes, ma'am.
Mm. Okay. When is your quiz 2?
It's on the 3rd August.
3rd of August. Yes, let's type that way too. So here you are taking common 6 into n plus 1, right?
Yes, ma'am.
So that will become 36 n plus 1 upon n, right? So now here you will get 2n plus 1 by n, and from here you will get minus what upon 6 also you have to take care because you don't have 6. So minus 5n minus 6, this will be minus how you have taken 6n plus 1 common.
Actually, first I multiplied 6
Divide
by
by plus.
Hmm. Okay, fine. Yeah. I'll check and let you know if that option in place of plus or minus, what is the option is correct.
okay, ma'am.
Okay. Yeah, that's what happened when you take n regular parts. I'll check and update in the mock test. Okay, if that's true, then that's true. Yeah, but such type of questions won't be there in exam, because it will take, this question itself will take 10 minutes, 10 to 12 minutes to solve, even though if you know the concept of Riemann sum, right?
Yes, ma'am.
Okay. Any other thing? Yes. Who raised their hand? Any doubt? Said. No. Okay,
Then
then if
question number 11.
question number
11.
of the mock.
Yes, ma'am.
Okay, using Taylor's theorem, find the upper bound of f of 2 minus q of 2 into the correct upper place. See, whenever you want to find of upper bound of terms, you know the formula, right? So the thing is, if you are using, so here which approximation they are using? They are using quadratic approximation. So if quadratic approximation they are using, the upper bound can be found by the uh, one step higher derivative. So that is the modulus of f of x minus q of x. This is less than or equal to of the x minus a the whole cube by 3 factorial of the max value you have to take in between x belongs to the interval a to x, whatever x is there, modulus of f triple derivative of x. Right? So this is the formula for finding the error. So here you have f of x is under the root of x plus x square by 2. Right? Is this formula clear to you?
Yes, ma'am.
This is just a error formula, how we found out the error. So if f of x is this, then f dash of x will become what? 1 by 2 root x plus 2 into x by 2, that is x only. F double dash of x will become minus 1 by 4 x to the power 3 by 4, 3 by 2, right? Plus 1. And if triple derivative of x will become 3 by 2 will jump over here, that is minus 3 by 8 into 1 by x to the power plus, right?
This
5 by
plus
2. Just a calculation. Plus, right? 3 by 8, 1 upon x to the power 5 by 2. This is the third derivative of f triple dash of x. Now, what will be the max in the interval? So, here what is a? Around the point. So, a value is 1, x value is 2, right? So, our interval will become 1 to 2. So, what we want to find out? We want to find out the max value of this function in the interval 1 to 2. Okay. So, what is the function? What is f triple dash of x? This is actually 3 by 8 x to the power 5 by 2. Okay. So, what do you think? Is it increasing function or decreasing
It's
function in
decreasing
this interval?
function.
It is
The
Decreasing
decreasing
function.
decreasing
function, right?
function, so you'll get the maximum value at the left end point. Left.
Left hand point,
Yes.
right? So see, this is actually a decreasing function. Why it is decreasing function? Because it's a function related to 1 by x type of thing, right? We know that 1 by x type of functions are actually decreasing function. So it is decreasing. So that's why max value happened at the left end point, which is x is equals to 1. So that is the max of x belongs to close interval 1 comma 2 of modulus of f triple derivative of x. This is actually equal to 3 by 8 into 1, which is 3 by 8 only. Right? So this is the maximum value 3 by 8. See, we got this value to be 3 by 8. We have this x minus a the whole cube. That is what? 2 minus 1 the cube, which is only 1 only. And we have 3 factorial. So that means this bound will become minus, sorry, x is 2 here. So f of 2 minus q of 2 less than or equal to, this is 2 minus 1 the cube by 3 factorial into max value. This is 3 by 8. So this is what? This is 1 by 6 into 3 by 8. So this is 1 by 16. Right? 1 by 16 you can calculate in the points. Is it clear how to find out?
Yes, ma'am. Thank you.
Yeah, so 80 to 90% cases you will get either decreasing or increasing function. You won't get any complicated value to find out this max. So 1 by 16. Yeah, 0.0625.
Yes, ma'am. 0.0625.
Okay, so for error bound, remember this formula. If you are using quadratic, your error bound will be given by the third derivative. If you are using linear, error bound will be given by the second derivative. Okay. And for error bound, these are the only two derivatives you can use. For linear, the formula will look like this: x minus a the whole square by 2 factorial max of okay, I have taken x, but u is there. U belongs to close interval a to x. You have to change the interval depending on the value of x and a. F double derivative in this case. Okay. Fine. Any other doubt? Any other question?
No, ma'am.
No, ma'am.
Okay. Okay, then all the best, guys, for your test. I'll upload the notes over the calendar. And that's all. So when is your second revision session? It's already done.
Ma'am, can you repeat?
Yeah, this is the last
Yeah, it is,
session, right?
ma'am.
Before the
Yes,
quiz.
ma'am. This is
Yes,
the
ma'am.
last. Yes, ma'am.
Mhm. Okay. Okay, then see you. Bye.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.